All right, we are on lesson 12-7. If you are in the future, if you're watching this video and you think that this is 12-7 for the normal lesson, we had to modify our current unit 12 to go faster to get to quadratics. So coming back here, this is just talking about simplifying square roots. We're not even going to touch the algebra of simplifying square roots. I just want to get some review on simplifying square roots because you're going to be able to, you need to do that in geometry, in algebra 2, in pre-calculus, and calculus. This is a very valuable skill. All right, so undoing a square root. When I undo a square root, what am I really doing? So for example, if I'm trying to solve for x, what would I need to do to both sides? Quiet raised hand. How do I undo a square root? Good guess. You don't divide. But it's one of those things. It's not multiply. Multiply and divide, not quite. Is there a quiet raised hand? How do I undo? Cohen?
Subtract.
No, not subtract, but good guess. Keep trying, guys. How do I undo things?
Find the factors.
Factors, not quite.
Find,
All right, let's go ahead and give you the answer. The answer is to square both sides.
That's what I was going to say.
That's what everyone was going to say, I think.
I was going to say x.
If you square both sides, a square and square root, they cancel each other out. This is the second biggest thing you should take away from this lesson. A square and square root cancel each other out. So that square and square root cancel each other out. That square and that square root cancel each other out. Cross them both off. When I square a square root, or vice versa, when I square root the square, I always eliminate both of those. They are canceled out. Let's literally write down that. So taking the square root of the number is the inverse operation of squaring the number. You write that down. See if you can get that just from me saying it and not writing that. Taking the square root of the number is the inverse operation of squaring the number. Multiplying by itself, I guess, is squaring. Taking the square root of a number is the same, or is the inverse operation of squaring the number. These two are opposites of each other. They undo each other. If I want to undo the square, I need a square root. If I want to undo the square root, I square. That's how you go back and forth. It's like adding and subtracting. Squaring is like adding, subtracting is like square rooting. They go back and forth. They are inverse operations. We're nodding our heads. We're following more or less. Some of us are waking up. Ish. All right. Let's come down here. This relates to our warm-up. The question is, why does the square root of 8 equal 2 times the square root of 2? And here is the answer. And I can go through this a little bit faster since we saw it on our warm-up. If I look at 8 and I do a factor tree of 8. Someone help me out with this. Quiet raised hand. Go for it, Jose. 2 times 4, and 4 is 2 times 2. And I'm going to circle all the factors. Circle, circle, circle. That way I don't get confused with 4 and 8. Those are my factors. I have 2 times 2 times 2. Those are the factors of 8. So thank you, Jose. You can turn in your card. So what I'm going to do is I'm going to make pairs. Not apples and pears, but pairs as in two things, like a pair of socks. So my first pair is I'm going to go down here. I'm actually going to make a rectangle around those two pairs. And I can't make a pair with the other factor, so it's going to have to stay inside. Whenever I make a pair, that comes to the outside. So I'm going to say this is going to be on the outside. This remaining factor 2, that did not have a pair. That's going to have to stay inside. It does not get to go out and play. It has to stay inside. When I say inside and outside, I really mean inside or outside of the square root. Notice that when I do the square root of 8 here, everything is on the inside of this radical symbol. So to move it to the outside, now I have 2 on the outside. So I can move these 2's to the outside, and on the inside I still have square root of 2. So 2 came here to the outside. I can color code this to make it easier to see. Then I have the square root. On the inside I still have a 2, and that was our green. That's why square root of 8 is equal to 2 square root of 2. The pairs go on the inside or the outside. The non-pairs stay on the inside. That's what we're literally going to write down for the procedure. I'm just showing you this procedure. Then I'm going to talk about the procedure. Then we're going to apply the procedure. All right, so what was this thing that I did with 8? What is that called? Quiet raise hand, Monse. Factor tree. Make a factor tree. Thank you, Monse. Make a factor tree. All right, pairs of factors go where? Is that the inside or the outside? Quiet raised hand, easy XP, Jessica?
Outside.
They go on the outside. Jessica got some XP. Boom, bada boom. And Gunner. Inside. Gunner got his XP. All right.
I think I just moved down.
I don't think so, but I appreciate
Did you
you
not hear me
attempting to get your peers XP.
Yelling.
All right, give me a fist of 5. How well are you following for the entire lesson up to here? 5 is I'm following really well. 1 is I just woke up. Andres, did you just wake up? Gunnar, you've been following more than 1. You were participating.
No.
All right, thank you.
Participation.
Example 1. Who can do the first step for example 1? Josie, thank you. You're doing the factor tree already. So 27 is 3 times 9. And 9, Josie, is 3 times 3. And let's circle all those factors. Thank you, Josie. We have a factor of 3, a factor of 3, and another. Wow, it's just 3 times 3 times 3. Cool, cool. Josie, there you are. And Josie can turn her card in. Next step, and our final step. Who can tell me the answer? Who can do the pair stuff for Nando?
3 to the root of 3, right?
It's 3 root 3. Why? What pairs did you make?
The 2 on the bottom.
So those 2 go on the outside.
Yeah.
And the one that is not a pair, like this one, goes on the inside. And he told us it was going to be 3 square root of 3. All right. I'm going to pause here. Conceptual question. Big picture question. Why? Why am I allowed to put a pair on the outside and the non-pair on the inside? Thinking deeply before we go too fast. And if you say, because Mr. Sindel told you so, I am going to shudder because that is never the answer. There's always a mathematical explanation. It does not involve precipitation. But it does involve that rule from the very, very top. I did give you the ammunition. You just need to figure out how to use it. Why? Let me ask a scaffolding question here. How can I rewrite 3 times 3 in terms of powers, quiet raised hand? 3 times 3 is rewritten as quiet raised hand. Sergio?
To the power of 2.
There it is. So this guy right here is 3 to the power of 2. Thank you, Sergio. That's going to help us a lot. So, come on, let go. There you go. If this can be rewritten as 3 to the power of 2, and this is still 3, I can rewrite this square root of 27. I'm going to do it down here. Do it with me. This square root of 27 is the same thing as 3 squared times 3. Which is the same thing as, I can separate these. Whenever you have a multiplication symbol inside of a square root, you are allowed to break it apart. I can break it apart into 2 square roots. My first square root is 3 squared, and my second square root is just 3. Now that we've done that scaffolded question, how can I rewrite this problem beneath this square root of 3 squared times square root of 3? How does that somehow transform into 3 times the square root of 3? Using that rule from the very, very top, which we haven't used yet. Can someone quietly raise their hand and tell us why? And Sergio, you can turn in your card. You did the last question. Why? Well, it's pretty easy to see that square root of 3 to square root of 3, that's the same thing. How do I get from square root of 3 squared to just normal square root of 3? How do I do that yellow? Anyone have any ideas? No one is raising their hand. That's not good. We're using this rule from up here, where if I take the square of a square root or the square root of a square, it cancels out the operation. Can someone use that rule and tell us how the square root of 3 squared turns into 3? Not a one of us still? All right, I'll give it to us. Whenever I square root the square, those are inverse operations. That means that square root and that square cancel out. I'm only left with just 3. Cross out in your notes too. The square root and the square, whenever you have both of them on top of one another, they always cancel out. That is the reason why we have 3 radical 3, because the square root and the square cancel each other out. That's the main reason. You also had to know the trick that 3 times 3 is the same thing as 3 squared. All right, give me a fist of 5 on that last part. How well did you follow from 3 squared to here, to here, to here? Give me a fist of 5. Oh, those are pretty high scores. Question, yeah, Andres.
Can you also do that on the left side, like 3 to the power of 2 times 3, like the square root of that?
You can. This is showing the work a little bit more because you do have to separate them into 2 parts. You have part 1, part 2. But yes, if you can see it from here to go straight to the answer, then yeah, that's good. All right, those were pretty high scores. Okay, let's go to example 2 and be done with the notes. Example 2, quiet raise hand. Someone help me set up the first step of the procedure. Example 2, quiet raise hand. I see people that have hands with no cards. Is there anyone that has a card? Andres has a card. Go for it.
Okay, so you make a factor tree of 80.
Okay.
And then it's 8 times 10. 8 and 10.
8 and 10. Okay. 8 is going to be
4 and 2.
4 and 2, and 4 is going to be
2 and 2.
2 and 2, and 10 is going to be
2 and 5.
2 and 5. Okay, our pairs are going to be a little bit harder here. Andres, you can turn in your card. That's a good job doing the factor tree. I need someone else to start doing the pair of this. Pair them up.
I think Fernando should turn in his card too.
All right, is there someone that does not have their card in that can pair up these factors? Cohen, do you have your card in, Cohen? I mean, you have your card physically, but were you supposed to turn it in?
No, I don't think so.
No? Okay, Cohen, go for it. What are our pairs?
2 and 2.
So I got those 2's on the bottom. Are there any other pairs that you can make?
The other 2 and 2.
Ah, the other 2 and 2. And then what's left over?
5.
All right, that one's left over, so that's on the inside.
Wait, why is 5 on the
Because 5 didn't get paired. So non-pairs stay on the inside. All the pairs go on the outside. So these pairs go on the outside.
Gunnar did help me.
I will give the XP for it because I did hear him. And then Cohen, go ahead and write our final answer. It actually might not be a final answer, but do the simplified version of square root of 80 using our outside and inside rules. How many 2's do we have on the outside?
2 to root of 5.
Like that? You're really, really close. There were 2 pairs of 2's though.
2 times 2.
Yeah, so on the outside we have 2, and then times square root of 5. So we have all of this. And that reduces to what?
4 to root of 5.
Yeah, 2 times 2 is just 4, so it's 4 square root of 5. Final answer. And I guess we should be boxing our final answer up here as well. Did I box my final answer up here? Not quite. There it is. All right, ask me questions on example 2. Thank you, Cohen. Ask me questions. Yeah, Jose.
So, does that mean you're putting 2 to the power of 2 right now?
Yeah, you could totally write it. So you're saying, could you do 2 to the power of 2 square root of 5 like that? Yeah, that's perfectly fine. Both of these are the same form. This is usually more common in mathematics, but both of these are correct. You'll get points on Khan Academy for either of those. Any other questions? That was a good question. All right, go ahead and write your summary.